So, hello everyone. Thanks for being on board. As Jerry said, I'm working as a scientific programmer. That's actually a part-time job. And the other office hours in my week, I volunteer as an open source contributor. And that's the context of my talk today. So, for those people who don't really know underscore, I'll give a quick introduction and then I'll explain why I decided to make underscore modular, then how it works and how you can use it, and then I'll have some closing words. So, introducing underscore. I'll show my terminal just to demonstrate how underscore works. Underscore is actually three things. Firstly, it's this missing standard library for JavaScript with all these functional utilities that you need in nearly every application. So I've written an import line over here. And you see this default export, which is called underscore, which is why the reason why the library is named like that. And then there are three examples of functions which are exported by this library, which I imported by name. I'll demonstrate them right now for you. So I'll start with defining a few functions that I can use with functions that are in underscore itself. So, for example, here's a function that will square any number that you throw at it. Here is a function that will add two numbers. And here comes the first demonstration of something you can do with underscore. You can compose functions. So now I've written a function that will add any collection of numbers. So for example, if I have an array with three numbers, and I take the sum, it will give me 6. I can also combine map and square, for example. And that will square every number in the array. Now, sometimes people remark that JavaScript nowadays has these functions as well. I mean, map and reuse are in JavaScript, but these are not the only functions in underscore, first of all. Secondly, the functions in underscore are much more powerful. So for example, map also works on plain objects. And suppose that I have an array of arrays, and I want to know the length of each array in the larger array. Then I can do this. Oops, forgot a brace. There. So that's the first thing that underscore does. It has these over 100 functions that you can use in nearly every application to make your code more concise and more maintainable at the same time. And secondly, this underscore object, it's actually a big chunk of magic sugar, which you can use to do all kinds of fancy things. So if you use it as a function, it creates a wrapper, which I'm demonstrating here. You can also unpack that wrapper again. So it has this implicit conversion to regular objects. You can also unpack explicitly if you need to. And this special function makes it possible to do chaining, which I'll demonstrate right now. So if I chain, say, an array, then I can, for example, map my square function over it, and then, well, take the size of the results. So I created an array of 3 things out of another array of 3 things. Maybe that's not so exciting, but there is this mix-in function. Right now I'm assigning it to result. That's not strictly necessary, but I'm doing it because otherwise I'll get a lot of terminal output. So I can mix in my own add, or no, sum and square functions. And now chaining works with them as well. Now I can suddenly square sum my square numbers. So that's 1 plus 4 plus 9 is 14. Or I can do it the other way around. So now these sum and square functions behave like methods of the special chain mechanism. So I'll add them, that will be 6, and I'll square it, that will be 36. And the trick is that all the functions that are in underscore itself, which are included, these work in the same way. They're just regular functions. They just take some parameters and they give you some output value. And the wrapping and the chaining is layered on top in a magical way. So that's the second thing that underscore is. It's firstly, it's a collection of useful functions. Secondly, it's magic sugar. And thirdly, it is code that is meant to be read. So I'll show the code. This is our bundle where all code is in one file. And you see that these comments are written in there like almost like a story which is continuous with the code. And we even have we use doco to turn it inside out, so you can see it in the browser, where this is just the same code you were seeing on the background. But now it's comments first and code in insets in between. So this is one of the main goals of underscore, to have this readable, instructive code, which might inspire you. And actually the mechanism through which the chaining is layered on top of all the functions is quite brilliant, quite inspiring to read. So that's a quick introduction to underscore. Now I should give you a quick introduction, well, more elaborate introduction to why I decided to modularize it, because this code that I just showed you, that's a bundle, single file. Underscore used to be manually written like that. And I decided to chop it into many tiny modules. So why did it go this way? Underscore was introduced in 2009, 11 years ago, by Jeremy Ashkenaz, who, by the way, also created Backbone and CoffeeScript. And it was wonderful. It became quite popular. And then 3 years later, John David Dalton came along. And, well, my animation, oh, there it is. And he thought, well, maybe underscore can be even better. And he decided to fork the library and create Lodash. And, well, he had some interesting extensions to the library. But Now there were two libraries, and this also had some disadvantages. So the first thing is that when you have two libraries, that means that when people make fixes to one, then the other library will not automatically benefit. And the second is that since they count as two libraries, if you have a few dependencies in your application, and some of them depend on underscore, and some of them depend on Lodash, then you might ship more or less the same library twice to your users, which in a web application is not ideal. Well, at first, Lodash and underscore were kind of interchangeable, but Lodash really moved in a different direction. So many functions in these libraries were renamed in Lodash. These are just a few examples. There are actually many. There were also quite a few that were split into different variants of the same function. And as time progressed, Lodash became more and more different from underscore. So people were increasingly forced to really bundle both libraries when publishing their web applications. And especially Lodash is not the smallest, so this is a bit frustrating. So this is a situation I wanted to fix. I wanted to have a library which had all these function signatures with both names of both libraries, so I could have a single library that I could use instead of both underscore and Lodash in all my dependencies. So I would need to ship only one library to my users. And I wanted it to be as small as possible. One thing I could do is fork the library. But then we would have three libraries, and that would make the problem only worse. So I realized I needed to do something different. I needed to improve code reuse. When you fork a library, then basically what you're doing is not reusing the code that was already there, but creating an alternative. And I didn't want to create an alternative. I wanted to reuse what was already there, so that if underscore is improved, then my library would improve automatically as well. One other thing I could do was create an extension library like underscore contrib, where you just take underscore as it is and add more functions using the mixing mechanism. But I wanted to make my library as compact as possible. And this required that I might leave out some underscore functions if I decided to extend them in order to add some extra features that are also in Lodash or something like that. So I realized I needed to create tiny modules. Forking was out of the question. So why tiny modules? When you have a monolithic library, like underscore was in the past, it was a single file, and you import from it, then you automatically get the entire library. And now underscore isn't that large, but you might want to shave off a few kilobytes, and you can't do it. So if you chop the library into tiny modules, then you can still do the same thing. You can import this magical default underscore object from the library and have all its functions included. But you can also say, well, I'll just use one of its functions, and then you don't need to import all of it. And when composing my own library, this is something I wanted to use. I wanted to compose the library out of some parts of underscore, some of my own extensions, which would mimic the extensions in Lodash. So this is really what I needed. And this is also what I ended up doing. So I'll show how modular underscore works. This is the bundle, but it's actually created from the modules that we have in underscore. So here is the definition of the find function. It's one of the modules. This is all the code there is in the module. It internally depends on other functions that are in underscore. Some are internal, like this is array-like. Starts with a underscore to indicate that it is an internal module. And then there are these external modules, the find index, the find key, just the regular underscore functions. So all these functions are just regular functions, each defined in a separate module, which might depend on each other. And then we have our internal index module, which basically lists all the functions that we have, since they are default exports. They don't have any intrinsic name. So in this index module, we choose the names for these functions. So we decide that the default export of the find key module will be exported by the find key name. Of course, I could define them as named exports in each module, but then firstly, the names would be fixed. And secondly, it's kind of awkward if you use it in older module systems like AMD, which we really want to support in underscore, because it is an old library and there's a lot of code that depends on it. So we need to be as compatible as possible with as many module systems as possible. So we have these default exports, and in the index module we define the names, and some of these functions have two names. For example, find actually is also named detect. And when I scroll down, you see a few more of those. So for example, reduce even has three names: reduce, fold L, and eject. This is to make this was already the case in the old monolithic underscore, but we retain it. And the reason for these names is that in other languages, many of these functions are present in the standard library, but they go by different names. For example, fold L, that's a Haskell name. Reduce, that's the name it goes by in Python, and probably in a few other languages. And I know that in C++ it's even called accumulate. So we have this index module, and it takes all the functions and it gives them names, sometimes multiple. And the way native ECMAScript modules work, it means that when you do import star from this module, then you'll get a plain object with all these properties. And we still need to layer the chaining magic on top of it. So we have a second module, the index default, which does exactly that. It takes these named exports from the index module, and it also imports the mixin function. And then it just mixins all these functions to the underscore object. And that's what we export from this module. Now we have a module which has only a default export, which is the magical underscore object with all these functions mixed in. And that's for the older module systems, that's enough, because all those systems could only export a single thing. In AMD, you have one thing. It can be anything, but you're exporting only one thing. In CommonJS, which is used in Node.js, same story. If you use browser globals, then you are attaching some kind of property to the global object. And the UMD bundles, they combine all those approaches. So for the UMD bundle, which we're still building based on this code, we use this module to create a single file using rollup. But for ECMAScript native modules, you don't only have a default export, but you can have also named exports besides it. So we have one more index module, the the index all, where we just re-export this default export, the magical underscore object, and we also export all functions by name. And that's why I was able to do this, especially this part. Those are the named exports from the index all. So now underscore is modular, and I can create my library. But you might wonder, how do you use it? And I recommend you pick either of two options. Either you do the monolithical import, so you just import from underscore, which that's this, import from underscore. That's always the interface that is exported from the index all, so the one that has the magical underscore object, all those functions mix in. And that's easy. You can import, you can use. It's a small library, you get all of it. You don't need to think about whether you have everything you need. But if you want to shave up some kilobytes, then you can create a custom underscore, which I'll explain in a bit. And what I recommend against, which I'll also explain, is directly importing the individual modules in your application. So if you, which I'm showing here, if you import individual modules, of course, you're omitting the modules that you don't need. But some of your dependencies probably depend on underscore, and they might actually be importing the monolithic bundle, the UMD bundle, or the ECMAScript bundle. And in that case, that actually means, because your build tool probably doesn't recognize them as overlapping libraries, it will probably include these functions that you're importing directly twice. Once in a bundle that your dependencies are depending on, and once because you import them directly. So a custom underscore is a way to avoid this, which basically means you create these index modules yourself, which import the functions that you need. And you write your code as if you're importing the standard underscore. And then in your build tool, you tell it to secretly replace all appearances of underscore by your own custom underscore, and all your dependencies will use your custom underscore, which is smaller than the standard underscore. So I'll go over how this works one more time. So what you'll do is you will create your own version of this. You could copy paste the content of this module and throw out everything you don't want, or you could start from scratch and list just a few. You could add a few functions of your own, because every function can be an underscore function. And then you just repeat this pattern with the index default, where you take all exports and mix them in. And optionally, if you want named exports, you can also create the index all, where you export both the default and the named functions. I hope that's clear. Otherwise, please ask. And the underscore low-dash compatibility library that I'm working on is called underscore Fusion. I have a working version on my computer, but before I publish, I also want to modularize underscore contrib, because some of the extensions that are in underscore Fusion should be in an underscore contrib, and right now I can't easily add them because underscore contrib itself is not entirely ready for code reuse. So that's a step I'm working on right now. And then I'll publish my work in progress, which is _fusion. That's all. Thank you for watching. If you have any questions, please let me know. If you want to know more, I have a website. Underscore has a website. We both are on Twitter. And if you like the work I'm doing and you want to support, please support me on Patreon. Thank you very much.